Hey guys, sorry about that. I got a phone call and my video cut out. So like I was saying, if you are an even function, that means that when 2 goes into your function and 3 comes out, then when the opposite of 2 goes in, the same y value will still come out. The same positive 3 will still come out even when you plug the opposite of that x value in. That's what it means to be an even function. If you are an even function, both of these points will live on your graph. 2 goes in, 3 comes out, the opposite of 2 goes in, 3 still comes out. That's an even function. So if you are an even function and both of these are points on your graph, then that means your graph will have symmetry to the y-axis. So even functions have symmetry to the y-axis, just based off of the behavior of their points. All right, well, then if you are an odd function, well, an odd function by definition said when x goes into the function, y or f of x comes out, right? X goes into the function and y comes out. That's what this ordered pair says. X went in and y comes out. But if you're an odd function, when the opposite of x goes into your function, then the opposite of y or the opposite of f of x now comes out. So when the opposite of x goes in, then the opposite of y comes out. So the opposite of x went in and the opposite of y came out. So that means on an odd function, when 2 goes in, 3 comes out. But when the opposite of 2 goes in, now the opposite of 3 also comes out. These have to be the points that live on the graph of an odd function. So that means if you're an odd function, then you're going to have symmetry to the origin. Okay, well, our next identity is which trig functions are odd functions and which trig functions are even functions, and how will that affect their behavior, right? All right, so if you are the sine function, so it says what happens if you plug the opposite of theta in, right? Well, let's look at this. So technically, by definition, the sine of negative theta is going to equal the opposite of sine theta. And let me show you why. Okay? Well, if you remember, let's let theta be an angle who landed in quadrant 1. So he's an angle between 0 and 90 degrees. So theta lives right here in quadrant 1. That means if you're a point on the unit circle, the x-coordinate represents the cosine of that angle, and the y-coordinate represents the sine of that angle. Well, then you'd also have to imagine then if theta was an angle in quadrant 1, negative theta would have been an angle who lands in quadrant 4, by the way negative angles rotate around the circle, okay? So if I asked you, what is the sine of angle theta? Well, the sine of angle theta is equal to that y-coordinate. That y-coordinate represents the sine of that angle, okay? Well, then if I asked you, what is the sine of negative theta? Well, then the sine of negative theta is represented by his y-coordinate, which is negative y, okay? Now, simple substitution says that the sine of negative theta equals negative, who was y representing original? Sine theta. So it gives you basically a way to get the negative out of the angle and outside the function pertaining to the ratio. So the sine of negative theta is going to equal negative sine theta. All right, and we can even do it with degrees, if degrees help you. If I asked you guys, what's the sine of 30 degrees? Well, what's the sine of 30 degrees? The 30-degree angle would have a sine O over H, 1/2. And if he landed in quadrant 1, what would the sine of that function be? Would it be a positive ratio or a negative ratio? It would be a positive ratio. All students take calculus. All ratios are positive for angles in quadrant 1. So the sine of 30 degrees is 1/2. Well, what's the sine of negative 30 degrees? Well, guys, the sine of negative 30, here's negative 30, right? Who's his reference angle? 30. It would be the sine of a 30-degree angle, but he landed in quadrant 4. So what is the sine of a 30? It would still be 1/2. But what is your sine ratio in quadrant 4? All students take calculus, says that only the cosine ratio is positive, which means the sine ratio would be negative. So it works with angles as well, and you can actually give them number values. So look at how this works. 30 degrees went in and a ratio of 1/2 came out. When negative 30 degrees went in, negative 1/2 came out as the ratio. So you have x went in, y came out. The opposite of x went in and the opposite of y came out. That is odd function behavior, which means the sine function is an odd function, okay? All right. So now his reciprocal trig function is going to work the exact same way. So the cosecant of negative theta is going to equal negative cosecant theta, which makes them odd, right? X goes in, y came out originally. Now the opposite of x goes in and the opposite of y comes out. That's how these functions work. Those are odd trigonometric functions. So basically, anytime you have the sine of a negative angle, you can rewrite that by pulling that negative out and just taking the sine of the original theta. Okay? All right, what about cosine? Is cosine an even or odd function? Well, let's look at cosine now. All right, well, by definition, on the unit circle, the cosine of angle theta is equal to the x coordinate. So when angle theta is a quadrant 1 angle, his cosine is that x coordinate right there. So now, if I asked you to find the cosine of negative theta, the cosine of negative theta is the x coordinate for this angle right here, and his x coordinate is also x. So that means that cosine negative theta equals, well, what did x originally represent? Cosine theta. So basically the cosine of a negative theta is going to be the exact same answer as cosine of that original angle, okay? And we can do this with numbers. What if I asked you, what's the cosine of a 30-degree angle, right? 30 degrees would be, picture this as 30 degrees. His cosine would be a over h, it would be root 3 over 2. And what is the cosine of any angle who landed in quadrant 1? It's a positive value, so it's positive root 3 over 2. Well, what's the cosine of negative 30 degrees? Well, the cosine of negative 30 degrees, here's negative 30, right? Really what you would be doing is taking the cosine of a 30-degree angle, but he landed in quadrant 4. So what's the cosine of a 30? It's still root 3 over 2. And what is the cosine of an angle who landed in quadrant 4? Well, according to All Students Take Calculus, the cosine of an angle in quadrant 4 is a positive ratio. So it would still be positive root 3 over 2. So think about this. 30 degrees went in, and positive root 3 over 2 comes out. When negative 30 degrees went in, positive root 32 still came out. That's even function behavior. When the opposite of x went in, the original y coordinate still came out. That is even function behavior. So the cosine function and his reciprocal secant, they are going to be even functions because the cosine of negative theta is equal to the cosine of theta. And the secant of negative theta then is equal to the secant of theta. All right, those are even functions. When x went in and y came out originally, when the opposite of x went in, the same y still came out. That is an even function. All right, what about the tangent and the cotangent? Well, the tangent function works like this, right? The tangent of angle theta, by definition, is, am I on the screen? Yeah. The sine of angle theta divided by the cosine of angle theta. So in that case, the tangent of theta was sine over cosine. It was the y coordinate over the x coordinate. Okay? Well, when I take the tangent of negative theta, well, that's equal to the sine of negative theta divided by the cosine of negative theta. And we just learned that the sine of negative theta is equal to negative sine theta. So that's negative sine theta over the cosine of negative theta we just learned is the cosine of angle theta. So that's going to equal a negative Sine over cosine, a negative tangent theta. So that means that the tangent of negative theta is equal to negative tangent theta. Okay, so that means when the opposite of theta goes in, the opposite of that ratio comes out. All right, we can even do it with numbers. If I asked you guys, let's do tangent of 30 degrees. What is the tangent of a 30-degree angle? Well, tangent is O over A, right? So it's 1 over root 3, which is root 3 over 3. Okay, and if it was a tangent theta, he'd be in quadrant 1, 30 degrees. His ratio would be positive. Well, what about the tangent of negative 30 degrees? The tangent of negative 30 degrees would have landed here. So it still would have been the tangent of a 30-degree angle, but it would have landed in quadrant 4. And according to all students take calculus, only the cosine ratio is positive for angles in quadrant 4, which means the tangent of any angle in quadrant 4 would be a negative ratio. So that would be negative root 3 over 3. So 30 degrees went in, and root 3 over 3 came out. When negative 30 degrees went in, negative root 3 over 3 came out. So when the opposite of x went in, the opposite of y came out. That is odd function behavior. Okay? So that means the tangent function is an odd function, and so is his reciprocal. So that means the tangent of negative theta is equal to negative tangent theta. And the cotangent of negative theta is equal to negative cotangent theta, right? Because the way his function works is when x goes in and y comes out. We just saw when the opposite of x goes in, the opposite of y comes out. So that is odd function behavior, okay? So secant and cosine are the only even trig functions. All right. So let's put this to use. Let me show you. So you've been asked to find this before. You could literally do it by getting your reference angle, figuring out what quadrant it is, and working your triangles and everything. But what they want you to realize now is when you take the sine of negative theta, it's going to equal negative sine of that original theta. So the sine of negative 40 degrees can now be rewritten as negative sine 45 degrees. So now you're going to get a negative answer, and you're going to take the ratio for whatever the sine of 45 degrees is. So that means 45 degrees, that's negative. And then the sine of a 45-degree angle, well, if you go to your right triangle, that's root 2 over 2. So the answer is negative root 2 over 2. Okay? All right. Well, if you were asked to find the cosine of negative pi over 3, you have just learned that the cosine of a negative angle is equal to the cosine of that original angle. So this would be equal to the cosine of pi over 3. Because that's an even function. When the opposite of x goes in, the original y value still comes out, right? That original ratio still comes out. So what is the cosine of pi over 3? Well, guys, that's 60 degrees. Pi over 3, 180 divided by 3. So cosine pi over 3, what is the cosine of a 60-degree angle? Go work your triangle, and you should find out the cosine of a 60 is 1/2. And it's positive because your ratio for a cosine of a 60 is in quadrant 1, and that would definitely be a positive ratio. Okay? All right? If you were asked, what is the cotangent of negative pi over 6? Well, you have just learned that the cotangent of negative theta is equal to negative cotangent theta. So this is equal to negative cotangent pi over 6. Okay, so your answer is going to be a negative ratio. Now go find out what is the cotangent of pi over 6. What is the cotangent of a 30-degree angle? Go work your triangle, do whatever you have to do. The cotangent of a 30-degree angle, here, I'll show you. The cotangent of a 30-degree angle, right? Cotangent is A over O. So A over O is going to be root 3 over 1. So it's going to be negative root 3 then, because his ratio is root 3, and this makes it negative. It is negative root 3. Okay, I'll come back and I'll do the back of the notes in 1 minute.